Hi, my name is Dave Batson. I'm a senior engineer with Greenlight Group and I work with HP software products. Today we're going to look at creating a custom MIB expression in NNMI 9.0 to measure interface utilization.
Okay, so we're going to go ahead and look at creating a MIB expression to measure utilization across an interface. Let's see, we're here in the NNM 9.1x interface. Just for anyone who hasn't used this interface before, it's a little bit newer. It requires IE 8 or better, or Firefox 3.6 or better. In our interface here, we'll go to Configuration and MIB Expressions, and we'll see here that HP already has an interface utilization expression. Let's take a look at this. Now the problem with this built-in expression is that it takes the interface in octets and adds them to the interface out octets. Now that'll work fine if your interface is at half duplex. If you have an interface running at full duplex, you're going to get over 100% utilization if the in and out is at a high rate. So we can use this and adjust it to fit our needs here. So we'll just take this expression and we're going to borrow it. And then we're going to create an expression of our own. So we'll click the new button here. We have our blank expression and we can name that whatever we want. We'll just do the interface out. And open up our expression builder. Now mainly this is just to illustrate how this MIB builder works, because it can be a little bit frustrating at times. It's not exactly the most user-friendly interface. So we'll just put this down here so we can look at it while we build our expression. Now if we look at this, we have the left side of our expression here and the right side here. So we were going to do the interface out, so we'll delete the interface in. Which means we can delete this parentheses and our outermost. So now we have our adjusted left side of the equation and our adjusted right side. This right side is just to measure the delta of the counter. So first let's put in our operands. So our left side is divided by the right side, so we add the division sign. Now the left side of this equation is going to be populated first. So the first thing we have over here is multiply. So we'll bring in a multiply sign. You see that pops in on the left side. Then we have a division on the left side of that, so we click and highlight the multiplication and add a division on the left. And then we have one more multiplication on the left, so we highlight that division, add in the multiplication. So now that we have our operands built in there, we can go ahead and bring in our variables. So again, the left side is going to be populated, so let's browse to our interface out octets. So we'll click on our MIB variable button here, make sure that your multiplication right here is highlighted. Okay, now that's up, so we will browse down to our management MIB2 interfaces across octets across an interface are a standard MIB variable. So the octets in and out across an interface are in the public MIB2 OIDs. So we'll go down to MIB2 interfaces, interface table, interface entry, then we have interface out octets. That's what we were going to choose there. Now, one thing, if your device does not support, a lot of newer devices don't have 32-bit counters on them anymore. This is the 32-bit counter. If you were to use the newer 64-bit counters on a newer device, you want to come down this tree, interface MIB, interface MIB objects, interface X table, interface X entry, and then here's our high counters. HC stands for high counter, so here would be our interface high count out octets. But we're just going to use the 32-bit counter for our demonstration here. So here's our 32-bit counter. Click OK. So the left side is populated, and we need to multiply our octets by 8. So we have our constant value. We put an 8 here and then enter, and the right side of this multiplication is populated. Now we need to divide that by the interface speed. Now the interface speed is measured in bits, so that's why we have to multiply the octets by 8 so we can get the amount of bits that are actually moving across the interface. So let's go to our MIB browser again and populate the right side with the interface speed. Again, we'll go back down our management tree. Going down to the same spot, interface table, and then we will have interface speed. Click OK. Notice the right side of this is not populated because we have populated with this part of the equation. And then we will times that by 100 to give us an actual percentage value instead of a point percentage. This will come out with a real number for us. So we highlight our multiplication, put in our value of 100, enter that in, and so now we have the left side of our equation populated. Now, as I said before, we had our two sides. We have the left side and then the right side. So we have our left side populated. We highlight the division sign and populate the right side. So we have a multiplication here. We're going to get our delta. So we'll go ahead and use the multiplication and see that pops up in there. And we need to choose the sys uptime. Go back to our MIB browser. Management, MIB2, system, and our sys uptime. And then we need to multiply by 0.01. What that does is that translates ticks into seconds. And there we have our expression. So we'll go ahead and save that. And we can use NNM to do a live graph on this. So we'll go to Actions, Graph MIB Expression, and then we'll choose one of our routers here that I know has some traffic across it. That launches our real-time grapher, and for this to work you have to have Adobe Flash installed. And so now we see we have it is measuring traffic across this interface, octets out. So now that we have this MIB expression built and saved, we can apply this to a custom polar or integrate this into a custom actions menu item that we would want to use. And that's it. Thanks for watching.